In this video, we will be doing the last 3 pages of Module 6, Lesson 1. They're pages 8, 9, and 10. They're not labeled as 8, 9, and 10 though, I'll tell you that. They are labeled as Module 6, Lesson 1, Student Page C, page 4, 5, and 6. But if you're counting the pages, it's the 8th page, the 9th page, and the 10th page. So this will be the last video for this lesson. So in the previous video, we graphed 2 different scenarios for the cell phone bill. And the 2 major things we noted is that when the monthly service fee goes up, the y-intercept, which is the starting point, the least amount you can pay, also goes up by that same amount. When it was $6 for the service fee, the y-intercept was 0.6. When it was $10 for the service fee, the y-intercept was 0.10, meaning 0 minutes costs $10. 0 minutes costs 6. So we call that the y-intercept, which is the starting point of graphs in the first quadrant. So we're going to do 3 more variations. So hopefully you have 3 more colors, and we're going to compare how the slope changing. Remember, the slope is the rate of change. How fast is it changing by 10 cents per minute? And then I think we have another one with a y-intercept change as well. So we still need this page out, but next we will be going to, like I said, Module 6, Lesson 1, Student Page C, page 4. Okay. So this is variation 2. So we've had the original and we've had the first variation. Oh, there was one thing I wanted to tell you, just so we can keep these apart. So we labeled the original, but I would just put in small little writing above each one in the correct color what the equation was to get that $6 plus 10 cents per minute, $10 base fee plus 10 cents per minute, because it makes it easier to compare them at the end if you have them labeled. Okay, so page 4 of Student Page C, or this is page 8 of the packet. So variation 2. Suppose our cost per month decreases from 6 per month to 0 per month. There's another y-intercept decrease. So we should already be able to tell what the y-intercept on this graph will be. When it was $6, it was 0.6. If they didn't talk at all, you pay the $6. So if they talk 0 minutes on this plan, the cost will be $0. Because 0 per month plus 0 minutes would give us $0. So we can tell this one's going to have a y-intercept of 0, 0 based on the theories that we talked about. Just like this one had a y-intercept of 0.6. Talk 0 minutes, the cost is $6. Talk 0 minutes, the cost will be 0. Cost per minute stays the same, so it's still going to remain at 10 cents per minute. So I think we can make some predictions here. The new y-intercept 0, 0, but it's going to go up by the same amount as the other lines. The rate of change is the same, which means the slope or steepness is the same, meaning the 3 lines will all be parallel. So that's our prediction. And I think later they ask you for the prediction, so we can fill that in. So determine the cost if you were to talk 20 minutes. So first let's write our cost equations. So a $0 monthly fee plus 10 cents per minute. So basically we're only paying for the minutes we talked. No base fee on this one. So if you were to talk 20 minutes under this new scenario, so C equals 0 plus 0.10 M, and we're going to put 20 minutes in. 0 plus 10 cents per minute for 20 minutes. And we already said this is 20 dimes. 20 dimes is $2. So this cost would be $2. And then remember, we do have to keep our order pairs in the same order. And like I said, just put a little abbreviated version just to remind you, minutes are X, cost is Y, and we can tell that by looking at our graph. Minutes are X, the cost of the bill, Y. So next they say create an order pair. So how many minutes did I talk? 20. What was the cost? $2. And then use a different colored pencil and plot it on the graph. So 20 on the X, 2 on the Y. So 20 on the X and 2 on the Y. How do you think the plotted points will change in relation to the original scenario? So we just talked about the original scenario. We'll have a y-intercept of 0, 6, where this new scenario, if you talk 0 minutes, the cost will be $0. So we could say, how do you think the plotted points will change in relation to the original scenario? The y-intercept will be 0, 0 instead of 0, 6. And then so that's going to be the difference. And the similarity will be same rate of change. Which, let's just keep reminding ourselves, that's called the slope or the steepness of the graph. And that is 10 cents per minute. And that's rise over run. Rise 10 cents, run a minute. Rise 10 cents, run a minute. So it will have the same rate of change, which means the same slope. We don't really use steepness in math, but I'm just writing it now so you understand what slope means, how steep the line is. So the line will be parallel to the other two lines, except it will start at 0, 0 instead of 0, 6 or 0, 10. How do you think the plotted points will change in relation to really if you were to plot all the points 0 through 100 minutes for the scenario and variation 2? What difference enter? Okay, so we got that one answered. We can go down to our table and put 22 in, since we just found that here. Complete the table. Be sure to list the order pairs. Plot the points. Okay, so let's bring our equation down. 0 plus 0 times 10 cents per minute. And do I need the 0? No, I just have it there for emphasis because it's going to be my y-intercept. Y-intercept always has x0, and then this will be the y-coordinate of the y-intercept. So 0, 0. So like I said, I always do 4, make sure I got a pattern going, then I might jump down, or I might do 3 and then jump down and do the last one, just to verify the pattern's correct. So let's do this first one. So 0 plus 10 cents times 0 minutes, that would be 0 plus 0. So if you don't talk on your phone, your cost is 0. And then This one will be 0 base fee plus 10 cents for 10 minutes. And we know 10 dimes is $1. So 0 plus 1 will give us 1. So we can see a pattern there. And so up 1, up 1, up 1. So we can do 3, 4, 5, 6, 7, 8, 9, 10, and verify that these are all in order. They are. And then, like I said, I always check the last one just to make sure I haven't made any mistakes. 100 minutes. So 0 plus 0.10 times 100 is $10. Ding, 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 ding. So that verifies that we did our table correctly. So I don't have a problem with you doing that on the test, but just show me you've started some of them to establish a pattern. So we found 3 here, established a pattern, and then we checked it down here to verify that it's correct. So now let's go for it and start plotting. So our first 3 points, actually we have this one already plotted, 0, 0, and 10, 1. So 0, 0, just like we guessed, our y-intercept is 0, which means when you talk 0 minutes, the cost is $0. The second point was 10, 1. And what was the fourth point? 33. And so again, we've established a pattern. We know lines have the same rate of change throughout the whole line. So rise 1, run 1, rise 1, run 1. So we can do that all the way across the graph. And I'm not going to say it a million times this time since I can't say it that fast. Rise 1, run 1, rise 1, run 1. So there we go. So the last question said, did our prediction hold? Is the y-intercept 0, 0? Yes, it is. Is the line the same steepness or parallel to the other lines? Yes, it is. So plot your, or graph your line. And remember, don't go past 0. We can't go into negative minutes. Now we can keep talking, so the line does need to go on forever because we don't know how many minutes they talk. But you cannot let the line go here because that would be, if you extended the x-axis, this would be negative 10 minutes, negative 20 minutes, negative 30, and you can't have any negative minutes. So let's write that equation. So the cost is 0 plus 10 cents per minute. So now you can really see that number without the variable is always going to be the y-intercept, 0, 10, 0, 6, 0, 0. And the other deduction we can make is when the slopes are the same, and we'll learn in the next packet, slopes are the number in front of the variable, then the lines will be parallel. Same slope, same steepness. And you probably remember it from this in high school. Remember y equals mx plus b? So m is in front of the x, that's the slope. B is always the y-intercept, 0, comma b. These are just turned around backwards, but if you wrote 0.10 m, that would be this part, and then plus 10, 10 would be the b, the y-coordinate of the y-intercept. Okay, so last question was your prediction correct? Was the y-intercept 0, 0? Yes. Did it have the same slope? Yes. So we can put a big fat yes there. Same slope, different y-intercept. Okay, next page. And like I said, this does get a little tedious, but I think it's a good exercise to learn about slope and y-intercept before we formally introduce it in the next section. and future sections, it's going to be something we do for the rest of this class, is graph lines, which require a y-intercept and a slope. Okay, here's our third variation. So this time our cost is going to stay $6 per month, but the per minute charge is going to turn into 20. So let me remind you, the base cost, because if you were to talk 0 minutes, the base cost would be $6. That will always be your y-intercept, and the y-intercept always has x0. So the y-intercept is going to be 0, 6, just like the original line. But this number is bigger than 10, which means the slope is larger, which means the line will be steeper, because it's going up 20 cents for every minute. So y-intercept stays the same as the original, but this graph will be steeper because the slope is higher. Slope is rate of change, so it's always going to be like 20 cents per minute, $5 per hour, 3 feet per minute. So it's always going to have the word per in it, so it's easy to find slope, because slope is a fraction, 0.20 over 1 minute. Because remember how we learned per means division in Module 5? So this is going to be a steeper line because the slope is larger, and the y-intercept's going to stay the same as the original problem. So let's write our new scenario. So we haven't used purple yet. Let's use purple. So the cost is going to be the base fee, $6, plus 10 cents per minute. Oh, Kim. Read the problem. 20 cents per minute. So $6 plus 20 cents per minute. So to determine the cost for talking 20 minutes, so same old, like I said, these do get a little tedious, but I think in the end they make a good point. It's worth the little bit of tedium. So let's do this one. Oh, it's hard getting out of that glare. So 6 plus 0.20 times 20. Oops, syntax error. Oh, I'm glad I made one, because this is something I wanted to show you on the calculator. Anytime it says syntax error, hit clear, and it will highlight where your error is. Is this calculator amazing? $13.50 for this gem. It says, hey, why would you put a parenthesis in? There's not a parenthesis at the beginning. So I just hit DL. So I used a time sign, but then I typed in this parenthesis. Is that amazing? Because most students are like clicking on clear and typing it again. Don't do that. Click on clear once. It will highlight where your mistake is, and you fix it. It says don't put in a parenthesis if you don't have one open somewhere earlier in the problem. And so this is $10. So back to the basics, minutes, comma, cost. Write an order pair, plot it. So minutes, 20, cost, 10. So in a different color, go to your graph and plot the point 20 all the way up to 10. So 20, 10. Okay, did we do everything? Create an order pair, yep. Graph it, yep. Used a different color. Done. So now we can put 2010 in here. And let's do the two right before it, and then we'll discover the pattern. So cost is 6 plus 20 cents times 0 minutes. So this is 0. Anything times 0 is 0. So this is 6. Cost is 6 plus 20 cents times 10 minutes. So I'm just going to do it in my head because save time. So 10 times 20 is 200. Move the decimal over. That's 2. So that would be 8. So now I've established a pattern. I can see for every 10 minutes talked, the total cost is going to go up $2. For every 10 minutes we talk, the cost will increase by $2. So I can complete the table 12, 14, 16, 18, 20, 22, 24, 26, and then just like on all the others, I'm not gonna not check it because that's the whole reason we were allowed to do the pattern, just so we make sure and check it at the end. So 6 plus 20 cents times 100 minutes. So when you multiply by 100, it moves the decimal over 2. So that would be 20 plus 6, 26. Ding, 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 ding. So then we can be sure that our pattern's correct. Always do that check. You would be surprised how many times you'll catch an error. Okay, so 0, 6, 10, 8, we need to plot. 0, 6, 10, 8, and now we can see our pattern. Actually, let's do one more. I always like to do 4. 30, 12, 30 up to 12. And so now we can plot the rest of the points using our slope. And remember, slope is rise over run because all lines have a constant rate of change. Rise 2, run 1. 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 So there is our next line. So let's see what it looks like when we sketch the line. So always make sure your points are all in a row. Make sure you didn't plot any of them incorrectly, and you can see them all lined up there. Start at the y-axis or the y-intercept, go up. So let's see if our prediction was correct. Was the y-intercept the same as the original? Yes. Is the graph steeper than all of our other ones because of the higher per minute charge? Yes, it's going up much more quickly. So this one, I'm going to put the equation up here. So C equals, it was $6 plus 20 cents per minute. So y-intercept the same as the original, but the line was steeper. And let's see what's left on this page. Look at your new set of plotted points on the graph. Do your plotted points look different now that our cost per minute was increased from 10 cents to 20 cents? Describe similarities and differences, which we already did, but we'll just state them again. So the similarity hope that's right. Similarity. Yeah. Same starting cost, or we mathematically call that the y-intercept. Zero minutes, $6. And that would be 0, 6 as an ordered pair. So the y-intercept for both graphs were the same. The difference is this graph was steeper than the original graph. Because the rate of change, and later on you're going to learn that rate of change is ROC, so I'm just going to write that just because we're running out of room. This graph was steeper than the original graph because rate of change was larger. And we could say 10 cents per minute turned into 20 cents per minute. So that way you have the full description there, so when you're studying this, you totally understand why the graph was steeper, why they had the same y-intercept. And last, how does the cost change? For every, we already talked about this, 10 minutes talked, so plus 10, plus 10. For every 10 minutes talked, the cost, of course, it's increasing, increases. For every 10 minutes talked, the cost increases by $2. $2. $2. So that's what we put here. So for every 10 minutes talked, now the cost increases by $2. Okay, we're down to our last page of Module 2, the final variation. This is the last page of this video and the last page of this lesson. It's page 6, student, module 6, lesson 1, student page C, page 6, but it's actually the 10th page of the packet. Okay. So on the videos, I labeled it as page 10, 8 to 10. Okay, here we go. Last one. Let's do this. Suppose our cost per month is $6 per month, but the cost per minute changes from 10 minutes per minute to 5. So instead of the rate of change going up, now the rate of change is going down, which means we'll have a flatter line. Larger slope or rate of change, faster the line goes up. Smaller slope, it goes up more slowly, so it will be a flatter line than any of the others. It won't be as steep. But does everyone agree it's still going to have the same y-intercept? So if you talk 0 minutes, because y-intercept, remember, always has x0, and 0 is minutes, so 0 minutes are still going to cost $6. So same y-intercept as the original. And then the rate of change is 5 cents per minute, which means flatter line, which is another way of saying less steep. So a flatter line. Smaller rate of change, same y-intercept because the per month charge is the same. Okay, so let's rip through this one. So new equation, $6 per month plus 5 cents per minute, 20 minutes again. 6 plus 0.05 times 20. And let's write our order pair there, minute, comma, cost, so we don't get the order messed up. And we already know the minutes, so we can put that in and get it ready. And then go to our calculator. So 6 plus 0.05, and I know that's not necessary. I'm just trying to practice proper math notation, times 20 minutes, and that is going to be $7. So 27 is going to be our fifth line. So when X is 20, Y is 7. So when X is 20, Y is 1, 2, 3, 4, 5, 6, 7. So did we do everything? Find the new cost, make an order pair, graph it, different color. Done, done, done. How do you think the plotted points will change with the original? And we already stated that at the beginning when we were reading it. Same y-intercept or starting cost, 0.6. So same y-intercept, which is what we call in math, but in this scenario, it's the starting cost. So 0 minutes, $6. So that part stays the same. Same y-intercept, starting cost, because it's the monthly fee. So that's the part that's going to be the same. What's going to be different is different rate of change, which means from 0.10 per minute to 0.05 per minute means the line will be flatter. Because it's a smaller slope or smaller rate of change. Slope and rate of change are the same thing. Rate of change is kind of the fancy name we use as we go up in our math levels. So you learned it as slope in high school and college. Mostly they call it rate of change, but they're the same thing. So it went from 0.10 cents per minute to 0.5 means the line will be flatter because of the smaller slope. So let's put our 27 in and repeat this process again, but it's the last time. Like I said, it's a little tedious, but it's a good learning exercise. So let's bring our equation up so it teaches you about slope and about y-intercept. I love that about it. Okay, so we have $6 plus 5 cents times 0, so we can do that one in our head. That's just going to be 6. And then the next one, $6 plus 10 cents. Whoops, Kim. There she is again, getting all excited to get done, just like you guys are. Make a mistake, 10 cents. So I'm guessing that's going to be $6.50, but let's verify it. 6 plus 0.05 times 10. No parenthesis, Norris. 6.5, which means $6.50. So I think we've established a pattern. We're still going to check the last one. Remember, we don't take risks, especially on a test. So up 50 cents, 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 up 50 cents. Oops, I guess I didn't need to write that. 10.50 and 11. So let's check that we did that correctly. So $6 plus 5 cents times 100. And again, we can do this one without the calculator. Multiplying by 100 moves a decimal five places. 2 places to the right. So that's going to turn into 6 plus 5, which is 11. So we can verify that we did our table correctly. And then we got to put the points in. So 0, 6, 10, 650. So 0, 6, 10 goes up to 650. 1, 2, 3, 4, 5, 6. 650 would be right in the middle of 6 and 7. So now we have a pattern, but it's a little bit different than our last ones. Up a half over 1. 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 Rise a half, run 1. Rise a half, run 1. Rise a half, run 1. And we'll just go until we cross this line. Rise a half, run 1. 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 There we go. So we want to lay our straight edge down and make sure that all of those points are lined up. Because if you have a point out of order, that's wrong. They all have to be in a perfect straight line. Looking pretty good, wouldn't you agree? So 0, 6 was our first point. And so we start at the y-axis and all the way to the end of the graph. And then we can label that one as C equals $6 plus 5 cents per minute. Did we label all of them? Yes, 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 and yes. Yep, they're all labeled. So that'll be a good thing to look at later and go, oh, okay, so these all had the same y-intercept because they all cost $6 a month. This one was a higher y-intercept, $10 a month. This one was lower because it was a 0 per month fee. And then we can see the slopes. 10 cents a minute, all the slopes were the same. When we increased the cost to 20 cents per minute, it was steeper. When we decreased the cost to 5 cents per minute, it was flatter or less steep, whatever word you want to use. Okay, so let's see if we have everything. Ooh, one more question. Dang, they're just not going to let us go, are they? How does the cost change? So when we look at the table, add 10, add 10. So every 10 minutes talked, the cost is still going up. Obviously, it's not going to go down. Increases, and this time it increases only by 50 cents. So by $0.50. So we don't use cents because this is in dollars. So that's why we use the $sign to represent 50 cents. Because I'll see students do this on a test and then they'll plug 50 into the equation when it should have been 0.50. So if this says dollars, we do not use cents. This is red 50 cents, but we just use it with the $sign. So up 50 cents, up 50, up 50. Okay, so that's the end of Module 6, Lesson 1. In Lesson 2, you're going to learn more about graphing, more about slope, more about y-intercept. Okay, I'll see you then. Take care.